Okay, so now we're going to be discussing about superposition. So what is the idea of superposition? Well, superposition, we are taking independent, linear parts of a system and evaluating its effects on the system. So, for example, in the case of one battery source, let's say that this one battery source affects this resistor in some sort of way, maybe gives it a current of 20 milliamps. That's okay. But when we cascade multiple batteries together, like so, now we get more current that can be drawn onto the resistor. So maybe if it's to be consistent, if there's three battery sources, maybe it now outputs 60 milliamps of power. But in a similar way, what I could do is evaluate them one at a time. So let's call this one, let's call this two, and let's call this three. I say that the current I1 that is generated by this battery source, ignoring the other two, is 20 milliamps. And then maybe similarly, this is also 20 milliamps. And then similarly, this is 20 milliamps. So I took apart different battery sources and, just to pretend, what if we kind of ignored these two and we looked at them one at a time. How this battery affects this circuit, how this battery affects this circuit, and how this battery affects this circuit. And by knowing how each part affects the overall circuit, when we ask what is the current for this situation, we're able to kind of combine each superposition case together and allow us to get our final result. If you notice, for our situation, just to kind of ask a hypothetical, if we add these three together, they total 60 milliamps, just like we expect. Now, this then raises the question: why exactly do superposition? We have DC sources, and therefore we can always apply nodal, we can apply mesh, we can even apply KCL and KVL. The reason is because superposition becomes the only method to evaluate any other kind of sources. Not every source is going to simply be a linear battery that, you know, will just power up and reflect on a resistor. You might have complicated sources. You have maybe pulses. You may have sawtooth generators. You may even have a sinusoidal, and then this would be evaluated onto a resistor, for example. How do you evaluate this in the situation that it is not DC? Well, we would then have to use superposition and evaluate how each source affects the resistor overall, and then we can combine them together. So, in short, resistor or superposition becomes a very useful method and becomes the only method when we're evaluating signals that aren't constant, such as in the case of DC. So, how do we use superposition? First, let's evaluate how we go about doing so. One, take one source at a time, one independent source at a time. Note you cannot kill dependent sources. They're always going to reflect as part of the circuits. Two, if you have a voltage source, turn it into a short. If you have a current source, turn it into an open circuit. But not both at the same time. So if you have a voltage source like so, and then you have another voltage source like so, resistor here maybe, and then maybe you have a resistor and a current. There's 3 superposition cases that we have to test. This one, this one, this one. Therefore, kill one at a time, and then evaluate how that affects that circuit, and then move on to the next case until you get to your last case, to which then combine all cases. Combine all cases. And that's it. So to practice this, let's demonstrate it using an example. So suppose you have the following circuit. And we're going to go with very illogical values just to kind of demonstrate our point. Let's say this is 10 volts. That's okay. But let's say this is 5 amps. And the resistances here is going to be 1 ohm, 2 ohm, 3 ohm. And we want to know the voltage crossed here, V out. Okay, so to practice what this procedure tells us, we first identify our sources. We have one source, we have 2 sources. So we give us 2 cases. I'm going to take a look at case 1 first. So in order to look at case 1, I keep this source, but I kill the other source. That means that the 5 amps becomes an open circuit. So let's take a look. We have 10 volts. Now, in this situation, you have something like so. In this case, we cannot necessarily say that, whoops, swap the 2. In this case, we can't say this is V out. We reflect this instead as V out 1. So in this situation, V out is going to be the sum of V out 1 plus V out 2, because we have 2 different cases. So we have to first find V out 1. Now I want to point to you something. Notice that this current, if we look at this logically, if the current gets divided, there's not going to be any current that goes into here, because we treat open circuits as resistors with infinite resistance. Therefore, there is no current here. So we're only really looking at a circuit like this. V out 1, 1 and 3. This is 10 volts. And from there, V out 1 is just going to be a voltage divider. 1 divided by 1 plus 3 times 10 volts. Or about 10 over 4 volts, or if you like, 5 over 2, or 2.5 volts. That's okay. So keep that value in mind. Now let's take a look at the second test case. So I'm going to turn now 10 volts into a short circuit, because now we're looking at case 2, which is the current source. Okay, so we have now something like so. 1, 2, and 3. And the voltage source is reflected here as V out 2. Now, in this situation, what ends up happening is that the current will be divided into the parallel combination of 1 and 3. So the voltage actually in this situation is just going to be the same as V out 2 equal to basically 5 amps times the parallel combination of the two. So we have in this situation 1 in parallel with 3, and that's our going to be our voltage source, our equivalent voltage, or that's going to be our superposition voltage for case 2. So we have 5 amps, and then we have 1 times 3 divided by 1 plus 3, which gives us about 15 over 4, which we can't simplify that any further, but this is roughly about 3.75 volts. So that's okay. Neither of these are negative, so we're okay. And even if it's negative, it should be fine. Now, we have both of our values. All we need to do is put it together. So there, we find that the voltage, therefore, is going to be 2.5 volts plus 3.75 volts. Or if we like, this is going to be, so we have 2, and then we have 5 points, and then carry the 1, that's going to be 6.25 volts. So that's going to be the voltage output. Now, of course, doing a problem like this, you can clearly see it's not helpful for us to use DC, or to use superposition in the case of DC analysis. But this is just for us to demonstrate the fact that we can. So I hope this is helpful, and thank you.